farmers, you're being asked to reduce your greenhouse gas emissions by 25% by 2030. But it can sometimes be difficult to identify where the starting point on that journey to improved sustainability actually is. My name is Siobhan Kavanagh and I'm working with the Signpost programme, and I'm here to talk about the first steps to reducing greenhouse gas emissions on farm. Firstly, we're going to take a look at where the emissions actually come from. So methane, which is our main gas, it comes primarily from the livestock sector, so from cattle and sheep, and is primarily belched out through animals. But there is also some methane emitted from slurry management. Our second gas is nitrous oxide, and that comes primarily from fertiliser spreading, but also from slurry storage and from slurry spreading. And our third gas is carbon dioxide, and that comes from diesel and energy use on farm. The first step to reducing greenhouse gas emissions on all farms, the first step needs to be to reduce our reliance on chemical fertiliser. So that's the focus for the next couple of minutes. So how do we reduce emissions from nitrogen fertiliser? There's two main steps to doing that. Firstly is to reduce the overall quantity of chemical nitrogen that we're using on farm. Right now, the average quantity of nitrogen used on dairy farms is about 175 kilos per hectare. And on your typical beef farm, that's 56 kilos of nitrogen per hectare. The target to reduce that by is 20% minimum. That means 140 kilos of nitrogen on a dairy farm and 45 kilos of nitrogen on a beef farm. The main message here is we need to reduce our chemical nitrogen use on all farms by 20% minimum, and there's scope on all farms, regardless of whether you have a high input now or a low input, to reduce the quantity of nitrogen fertiliser being used. The second step is to replace the chemical fertiliser that is being used as straight CAN or straight urea, to replace that with protected urea. So protected urea has much lower emissions than either CAN or urea, having a win-win in terms of reducing our greenhouse gas emissions, but also our ammonia emissions. So we'll talk a little bit about both of those and how we might do this. So first, how do we reduce our chemical nitrogen use on farm without having a negative impact on productivity, so grass growth and crop growth? The first step to doing that is knowing what your soil analysis results are and using that information to make decisions around lime application, but also P's and K's to optimise those. Lime is the cheapest fertiliser that you will buy and has the potential to release up to 80 kilos of nitrogen per hectare. So it's a cheap source of nitrogen where it is applied. The second step is to make best use of slurry. It's a valuable nutrient on farm. Then there's 3 steps to making maximum use out of it. Firstly, get it analysed so that you know what the nutritive value of it is and you can make informed decisions as to where to spread it. Secondly, apply in springtime between February and May. And thirdly, apply it using low emission slurry spreading equipment, or LESS as we all know it as. It's a valuable nutrient and we need to get the best value out of it. By spreading in the springtime with LESS, you're tripling the availability of the nitrogen in your slurry, which is a significant saving. And thirdly, incorporating clover or multi-species swards into grassland swards. Numerous research projects have shown that incorporating clover has the potential to release or to fix up to 120 kilos of nitrogen per hectare. Again, a significant saving on your nitrogen bill and also good in terms of helping to reduce emissions because of that. Many farmers will use CAN as their straight nitrogen product, so why switch to protected urea as we are recommending here? Firstly, it's cheaper. So protected urea is about 25% cheaper than CAN right now, so there's a cost saving to individual farmers. Secondly, it grows the same amount of grass as CAN, so numerous studies across numerous sites have shown that protected urea grows as much grass as CAN. Thirdly, it has flexibility, so you have the flexibility to use it in the spring, summer and early autumn within the spreading periods, unlike straight urea, which can only be used in the springtime. And then finally, it has 70% lower nitrous oxide emissions than CAN. So it's a win-win for farmers. It's cheaper, it grows the same amount of grass, and it's also good for the environment. In summary, what are the first steps to reducing emissions? There's 2 key components to this. 1, reduce the quantity of chemical nitrogen that you're using on the farm, and the target is a minimum of 20%, but it's really how low can you go without affecting productivity. And secondly, replace whatever straight nitrogen products are being used on the farm with protected urea. So that's replacing CAN and straight urea with protected urea. Thank you.